All right, so we're going to go ahead and work word problems now with polynomial inequalities. This is, I know you guys, my students' favorite part of math is working word problems like this. It's just great. It says that a ball is kicked from the ground with initial velocity at 32 feet per second and can be modeled by s of t equals negative 16t squared plus 32t. And it asks you where or at what time intervals is the ball at or higher than or above 15 feet. So let's look at how we would actually set this up. So I have my S, this is not an F, that's an S. S of t equals negative 16t squared plus 32t. There's my model. And I need to know when is it going to be higher than, at what time. So I'm going to be solving for t. So I know that the S of t, not an F, but an S of t, did it again. Stop doing that. S of t is going to have to be, well, we know we're looking for 15 feet. So let's put this in. I've got 15, and I want to know when this is going to be greater than or equal to. Because I want to know at what times is it above 15 feet. So this has to be above 15 feet or greater than 15 feet. Because if you think of your y-axis, if I'm at 15 feet, above is greater than. So this part needs to be greater than. So negative 16t squared plus 32t. So that's what I'm asking you, is I'm asking you just to find t. That's it. All right, so let's look. So I'm going to go ahead and subtract this 15 and bring it over. So if you remember your rules from inequalities, when you add or subtract, you don't change your inequality. You only change your inequality is if you multiply or divide by a negative number, or if you take the reciprocal of both sides. 2t minus 15. From here, I'm not even going to mess with this. I'm not going to try to factor it. I'm not going to do anything. I'm going to jump right to the quadratic formula because this is a quadratic. So I can do my negative b. So negative 32 plus or minus the square root of 32 squared minus 4 times my a times my c all over 2 times my a. So whenever you have a quadratic, you can always use a quadratic formula. It's never going to fail you. As long as you do it correctly, it's never going to fail you. Well, this is what t is going to equal. So my t is going to equal, once you crunch out the math, 3/4 and 5/4. So that means at 3/4 of a minute and at 5/4 of a minute, we're exactly at 15 feet. All right, now we're ready to figure this out. Let's do a quick number line. So 3/4 is right here. Let's call this just 0.75. We can pick another number right here. Well, this is 5/4, so this is going to be 1.225. So I need to pick a number to the left. I want to pick 0 because that's easy to do math with. So here are my critical values. Here's my test values. I'm going to pick a number between 0.75 and 1.25. Well, 1's easy to do math with. And then I'm just going to go way out here to 10 because 10 is pretty easy to do math with. And what I'll do is I'm going to plug them back in. I'm going to plug it into this one because I'm confident I did my algebra correctly. And I'm looking to see if my value is going to be greater than or equal to 0. So if I put 0 in here, I've got 0 is less than or equal to negative 15. That doesn't work. If I put 1 in here, I've got negative 16 plus 32. So that's okay. So negative 16 plus 32 gives me 16 minus 15 is 1. Is 0 greater than, is 0 less than or equal to 1? Yes, this works. And if I put 10 in there, it won't work. Now, these are going to be your square brackets because it's got the equal to, because I said at. And it's going to be in this time right here. So my actual solution, my time values in which the ball will be at or above 15 feet is going to be from, now we have to convert this to seconds. So 0.75 of a minute. So I decided to leave in my wrong analysis in this video simply because everybody needs to see that everybody makes mistakes in math. Even people that Do this all the time. Do it every day. What I was doing when I was working this problem is, for some reason in my brain, it switched to minutes, but when I scanned the problem, when I was starting to analyze my answer, I realized it was in seconds. So I decided to leave this in so you see that even I make mistakes, even though I've already worked these problems in advance. Is going to be, no, I'm now analyzing this wrong. All right, so no, this is 0.75 of a second and 1.25 seconds. So we are going to be between 0.75 seconds and 1.25 seconds. And that's it. I know I kind of wrote off, but this is a squared off bracket just like this. And those are your solutions. No conversions, anything like that, because you end up getting 1.25 seconds. It works out nice and pretty. That's it. Easy peasy, lemon squeezy. This is a free fall motion problem from physics. Not terribly bad. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.